We have been learning about magnets ever since elementary school, and we are all familiar with bar magnets, right? So in a bar magnet, it has a north pole and a south pole, and we most of us have done this experiment with these iron nails where we put the bar magnet and we can see how this iron nails or iron fillings get arranged. So what we did this experiment was to identify the formation of magnetic field lines around a magnet. So a magnet have two poles, a north and south pole, and also have this magnetic field. So Earth is also a giant magnet. So Earth should also have a magnetic field and the poles. So this magnetic field of Earth is known as the geomagnetic field, and it extends from the core of the Earth into the space, and it also has a north and south poles. So not to confuse this with the geographic poles of Earth, what we call the north and south pole usually, but these are actually really close to these geographic poles, but not exactly at the same point. So Earth has a northern magnetic pole close to the north geographic pole, and also a southern or a south magnetic pole close to the south geographic pole. Okay, so there is this line, this imaginary line connecting the magnetic poles, and that line is making an angle of about 11 degree with the line connecting the geographic poles, known as the rotation axis. So that is the axis about which the Earth is revolving. So so we can conclude that Earth has a magnetic field. But the real question is, how did Earth, like a giant celestial body like Earth, go to have a magnetic field? So that brings us to the dynamo theory. So dynamo theory is actually a theory used to explain the formation of magnetic field, the generation of magnetic field in celestial bodies like Earth or even stars. So this theory actually proposes a mechanism which can be used to explain the formation of this magnetic field for these planets and all. So in a dynamo theory, what we say is that the inside the core of the Earth, there is this dynamo which is producing this magnetic field. So we know that Earth consists of different layers. So there is this crust, then mantle, and then we have the core, the outer core and inner core. And the inner core is actually a solid metal ball, mostly consisting of iron. And then outside this, we have the outer core. And in the outer core, it is filled with iron, nickel, and other alloys. And this is in metal, like this is in liquid form, like it's in liquid form. So what happens is that the convection currents of this fluid metal in the Earth's core, which is driven by the heat from the inner core, causes is organized into rolls by the Coriolis effect, and this generates electric current, and this indeed causes the formation of magnetic field. Now let's look at what a magnetosphere is. So a magnetosphere can be considered as this region around a planet or any celestial body, which is a region where the charged particles of plasma are in the influence of that object's magnetic field. So Earth has a magnetosphere. Almost all the celestial bodies, or almost all the planets in the solar system, actually have a magnetosphere, but they are not the same, because the planets like Earth, Mercury, and Jovian planets, and some moons, actually Ganymede has a magnetosphere, and all of this have a magnetosphere known as an intrinsic magnetosphere. So this is because of the presence of this internal magnetic field, but this is not the case with Mars and Venus. They do not have an internal magnetic field, and for the same reason, they have what we call an induced magnetosphere. So the difference is that it's not developed by the presence of this internal dynamo which produces the magnetic field. So in the case of these two planets, so what happens is that the solar radiation or the solar wind will wrap around this, the magnetic field lines will wrap around the obstacle. So in the case of planets, producing a magnetosphere. So it will be having all the components of an ordinary magnetosphere, but it's called an induced magnetosphere. So coming back to Earth's magnetosphere, so in the case of Earth, we have this a large magnetosphere, and which has been crucial in developing and sustaining life here on Earth. So that actually protects us from the harmful rays and the particle, the solar wind that's coming from sun, and also the cosmic radiation. It acts as a shield which reduces the erosion, the atmospheric erosion, and it actually helps the life here on Earth. It makes the Earth a blue planet. So the here in the pictures we can see this actually shows the magnetosphere of Earth. So we have seen the magnetic field lines of a bar magnet, right? They are equally arranged, they are symmetric. But in the case of Earth, this is not the case. Here we can see the magnetic field lines are not symmetric. And the reason is that the solar radiation that is coming from the sun compresses the sun side of the magnetic field, causing it to look like that. And this extends over a region of 65,000 kilometers. And on the other end, that is on the night side, the other end of the magnetic field, it will be extended like a tail. So we call that a magneto tail. So that's all for today. So today we have learned about the magnetic field of Earth, how it is generated, and also we briefly introduced the term magnetosphere, and we learned about the magnetosphere of other planets on Earth. So that's all for today, and thank you.